Hi, this is Teacher Molly at the Junior Museum and Zoo, and if you've been watching Shelter with Science with me and Teacher Mikey, you would know that we've been talking about air pressure and storms the last couple of weeks, and I just want to do a couple follow-up at-home things that you could try to learn more about how air works and how you can be a meteorologist. So the first one is pretty simple, but you have to do it by the sink. Take a cup, fill it to the brim with water. Okay, so now it's full of water, which is a liquid, and you're gonna take a piece of cardstock and put it on top, and I might press it down a little bit to seal it, and then I'm gonna flip it upside down over my sink. And you're gonna notice the piece of paper stays up because air is trying to get into the cup, and it's pushing, but the piece of paper is blocking it. And as soon as that piece of paper moves, the air can get in, and now my cup is full of air. So remember, air takes up a lot of space, and air has a lot of weight and creates a lot of pressure. It's very strong, so the air pressure trying to get into the cup that was full of a liquid, this gas, this air was pushing up on my piece of paper. Once a little bit of air can get in, it pushes all the water out and will dump the whole cup. Try it one more time. This doesn't work every time. If there's any air inside, it won't be successful, so that's why you want to fill it up to the very brim. Push a piece of paper on top, make sure it's sealed. Okay, and then flip it upside down. Whoop! A little water came out, but there's still that air trying to push up, and that air actually sealed the paper around it, so this paper is being held up by water, by air, but once I let the water out, it dumps. So air kept the paper up. So this one's kind of tricky. Teacher Mikey tried to do this in her air pressure class with some mixed success. But basically, I'm going to take a can and I'm going to put just a tiny bit of water. This is just straight water that I filled in here at the bottom. Not too much. Just a little bit of water. And I'm going to put it on a hot plate. And I'm going to let it warm up. And we know that when liquid water heats, it creates steam. So I want to see steam coming out of here. It might be a little hard to see. It's not happening yet. It's going to take several minutes for this water to boil. See if I can take this tray and hold it up and see if we can tell when steam starts to come out. And this is really hot, so I don't want to touch it. Now what's happening is this can was full of air, and then a little of that air got pushed out when the liquid water went in. Now gas takes up more space than liquid. So as the water gets heated, the liquid is going to turn into a gas, and the water is going to take up more and more space inside this can, pushing out all the air. So all the vaporized water is going to push all of the air out of this can until we see steam coming out, which is that hot water hitting the cooler air outside of the can and condensing and looking like fog and then going up in the atmosphere. So liquids take the shape of whatever the container they're in, but they won't necessarily fill an entire container. Gas will always try to fill the entire container it's in, and because there's a hole in the top of this, the gas is actually going to come out. It's going to fill the whole container and then come out. And this gas is water. It's just water, and it's pushing out all the air. But it takes a long time for this water to get heated and turn into gas and fill up the entire container. So we just have to be patient, and we have to wait. Being patient is hard. Oh, I can hear it. I can start to see a little bit of vapor come out. I don't know if a little bit of glare on this. Oh, there's definitely some steam coming out. I'm gonna let it heat up a little more. I want there to be a lot of vapor coming out. I want all that air to get pushed out of my can. And this is what happens when you make tea and you heat up a tea kettle. And you'll hear that whistle. That's all the gas, the vapor, the water vapor escaping from the container that the liquid water was in. I think I can hear bubbles. Bubbles are made from gas and liquid. Definitely some steam coming out. So that means it's boiling. When it starts bubbling, it's starting to boil, which is one type of vaporization. Evaporation is when the surface of a liquid vaporizes, and boiling is when those bubbles are formed and the whole liquid is vaporizing. So I know it's pretty hot now, so I'm gonna take these tongs, because I don't wanna touch it because I'll burn myself. I'm gonna flip this upside down into a bath of ice water. Whoa! It crushed. So remember I said that all of the vaporized water was pushing the air out? So basically that air wants to get back in. It does not like being pushed out. And when I flipped this over, suddenly it wasn't on the hot plate. It wasn't warming up anymore, and all the air said, now's our chance to get back into the can. But it couldn't get back into the can because the only place for gases to go in was upside down into this water. So the air actually tried to go in through the walls, that high pressure air on the outside tried to go in, and it crushed the can, and it actually pushed down on the water surface. So when I lift this up, some of the water is actually gonna come out. And that worked pretty well. Look how crushed that can is. Hi guys. So if you want to be a meteorologist and be able to predict the weather, you need tools or scientific instruments, and I'm going to show you how to make one of those instruments right now. It's called a thermometer, and it tells you what the temperature is outside. That's pretty important because often extreme changes in temperature that happen pretty quickly will result in storms. So if the weather gets really hot all of a sudden, or it drops and gets really cold all of a sudden, you probably know that there might be a storm coming. So you will need a small water bottle. So one of the reasons the little water bottles are so great is because they have these thin caps that you can make a hole in. So make a hole in the top, which is what I just did. All right, so I'm gonna put in 2 ingredients, and I have a little Dixie cup, and this is just full of water. I'm gonna put some water into 1 Dixie cup, and I'm gonna take another Dixie cup, and I'm gonna put some isopropyl alcohol in. So this is just rubbing alcohol, but it evaporates at a lower point than water does. And I want it to be 50-50, so I'm gonna put the same amount of water in as rubbing alcohol. That's kind of a lot. Don't really need that much, but now I know that this is a 50-50 ratio, and I can actually pour some of it off. So I just want the bottom to be covered. I'll put that to the side. Maybe I can make 2 thermometers, like I have so much ingredients. And I want to color it. At first I was gonna color it blue, but then I was like, the bottle's blue. It is my favorite color, but I think I'm gonna color it red. I'm gonna put some food coloring in. There, now you can really see that liquid level. Remember, 50-50 water and rubbing alcohol. And I'm gonna put my cap on. And I'm gonna put a straw, a clear straw in through the hole. I want it to touch the bottom and then come back up a little bit so it's still in the liquid, but not actually touching the very bottom. And you will need hot glue for this. So I'm gonna take hot glue, and I want to absolutely seal the top here so that no air can get in. It's important that no air gets in. I'm gonna take another glue stick, and I'm sealing the cap shut, so around the straw and the cap. And I want to adjust this because I don't want my straw to touch the sides at all. Right here is perfect. I hold that. dry for a little bit. All right, so I let my hot glue dry, and now I want to see if it can tell the temperature. So what I'm going to do is I'm going to take my hands and I'm going to rub them together really fast, really hard, creating friction. So friction is kinetic energy movement when two things rub together, changing to heat, thermal energy, and actually creates heat. I can feel my hands getting hot. So I'm going to take my hot hands and I'm going to put them on my bottle. And I'm not pushing, but you can see the red part moving up my straw from the heat of my warm hand. So the higher up the straw the liquid goes, the warmer it is. And then I have an ice bath. I'm gonna put it in this ice bath and watch the liquid level move down my straw as it cools down. It's gonna go down, 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 cold, 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 moving down my straw, heating my hands back up. Let's see if I can get it to move back up again. You see it rising? It works best if I put my hands all the way around it to keep it nice and warm, but then you guys can't see it moving. And put it back in my ice bath. What you guys can do is put this outside in the sun or the shade and see if it's in direct sunlight, if the liquid will move up your straw, and if it's in the shade, if it will move back down, and if you keep it outside, you can check the temperature. I just have this inside at room temperature and I'm bringing it outside. It's pretty sunny today. So I'm gonna put this on a chair, indirect sunlight, and you can watch that liquid moving up the straw. So I'm not touching it, it's just in the sun. If you enjoyed those science experiments, join us this summer in person for our Invention Convention Camp with teachers Benji and Alyssa. If chemistry and physics and the history of science is not really your thing, join me down by the bay with teacher Yaz, and we'll be learning all about the natural wonders and wildlife of our bay. And if you're more into paleontology, geology, oceanography, and marine science, join teacher Mikey and teacher Jeremy for Planet Earth, Planet Ocean. And if you can't join us in person this summer, we totally understand. We will be offering virtual zoo camp with teachers Anne and teacher Arad from our zoo straight to your home.